Welcome back! You're here! So, it's always tough getting back into the swing of things after a break, but you're here, you're watching the video, so you've got the ball rolling, so I'm proud of you there. So, what we're going to do today in the video is just review these two equations. So, pause the video and write these two equations down on scrap paper. And then what you're going to do is also watch the YouTube video on graphing equations. It's just somebody else explaining how to graph equations in slope-intercept form. And then you can use the link to practice graphing. There's a little game I found. I thought that'd be more fun. It's interactive and it gives you feedback. In preparation for the quiz is review assessment. So the quiz is that I'm going to post will be on solving equations and maybe a little bit on graphing, and it will count in school tool. Okay, so this video, the other YouTube video, it's like 3 minutes and 41 seconds, and then the game on graphing, all in preparation for the quiz is assessment. Okay, so I just want to make sure you didn't forget a couple of things over break. You know how if we don't use it, we lose it. Like it's not like you were practicing this for fun over break. I don't think. Maybe you were. So this was from the notes that we took last time that we had class. So this is going to be our go-to method or strategy for solving equations from this point forward. So remember, the first thing you want to do is to simplify. And this is where, if I'm going to see any errors, this is where they happen. Because you want to make sure that if there's parentheses that you always distribute first. And then you want to cover up the sides. Remember, we cover up the sides and we combine like terms. After you've done the simplify part, then you want to check to see if the coefficients are the same, right? You want to see if there's a special case. If the coefficients are different, then just keep on doing what we normally do, which is to add or subtract the variable terms. You want to get the variable terms all to one side. After you take care of the fact that you have variables on both sides, you now have either a one or two step equation. So this could even be cut out, maybe taped to your math folder. Always have it next to you and always follow this strategy, whether the equation looks really, really big and scary or if it's even a smaller one, because I got to tell you, on the test, the smaller equation was the one that we missed the most. So starting with number one. Okay, starting with number one, sorry. We are going to follow this approach. So the first thing I want to do is simplify. So I do see that there's parentheses, so I'm going to take care of that first. So distributing means you're going to get rid of the parentheses by multiplication. So you're going to do 4 times x. Oh, well, we got a pink pen here. All right. 4x, and then 4 times, we want to think of it as positive 4 times positive 6, which would be positive 24. Okay, equals, let's distribute over here, negative 2 times, there's really a 1 here, remember, so negative 2 times 1x, negative 2x, and negative 2 times positive 9 is negative 18. Okay, are we done simplifying? So if you cover up, this is what I was talking about, cover up side. If you cover up this side, can you combine a 4x with a 24 or a variable term with a constant? No, we cannot. Same thing over here. We are as simple as it gets on both sides. So check to see if you have, at this point, a special case. So we're done with the simplify. We're checking to see if it's a special case. So how do we do that? We check to see if the coefficients are the same. And they're different. So that means that we are going to get one solution. So the next part is to check and see if there are variables on both sides. And you see you have a 4x on the left and a negative 2x on the right. So you do have to, at this point, deal with that. So you're not just going to combine this together and do 4x and negative 2x and just put them together and say it's 2x. There's a way that you have to do it. So you want to either add or subtract the entire term. So I'm going to add 2x because negative 2x plus 2x is 0. So that takes care of the variable terms on the right. But make sure if you add once to each side. This gives me 6x plus 24 equals negative 18. So I just took care of the move. And now we should have either a 1 or a 2-step equation. So for some of you, I'm still kind of shaky on this. I draw a line. That's to trigger, that whole 2-step process. and you want to get rid of the 6 and the 24. Which one do we get rid of first? Get rid of, we want to subtract 24, we want to get rid of the constant, right? So minus 24, once on each side. 6x equals, what's negative 18 minus 24? So make sure when you put it in your calculator, negative, no, that's not negative, negative 18 minus 24. See, you're not going to do minus negative 24. That's kind of the weird thing I'm seeing every once in a while. So that's how it should look. You get negative 42. And how do we turn coefficients into 1? Or how do we deal with this coefficient? We divide by the coefficient. 6 divided by 6 gives us our 1x. And negative 42 divided by positive 6 is negative 7. Okay. Next one. First step, simplify. So on this side, I don't see any parentheses, but I do see there's 3 terms. So it has to be able to combine. We have to be able to combine something. And in fact, we can combine the constants. This is typically where people will start adding, subtracting right now, which is fine. But it does cause, for some reason, it causes a lot of error. So I really, really, really want you to combine them first. So you bring down that 6x. And what is 1 combined with a negative 5? Negative 4. Okay, and then over here, cover this up, we can combine these are all constants right here. So negative 10 plus 1 plus 5 is going to be negative 4 plus 6x comes down. And now we are done simplifying. So the next thing we want to see is, do we have a special case? So to figure that out, we look to see if at this point in solving, if the coefficients are the same, and they are, which means you do have a special case. So look at it. If the coefficients are the same and the constants are the same, and these are the exact same expressions on both sides, and no matter what you plug in for x on the left, if you plug that same number in on the right, you're always going to get the same thing on both sides. There's an infinite number of possible numbers you could plug in because they are the same exact expression. So what do we say if this is the case? We're going to say infinite solutions. Don't forget, don't forget to tell me that. You know that. That's what it means. Don't just stop there and write, I don't know, anything other than that. Okay? All right, so this was our little refresher. I mean, I could have done a lot more, but hopefully that just puts you back into the swing of things. And so at this point, make sure you do the graphing and then do the quiz is. It goes in School Tool. Do your best job, and I will see you in class very soon. Have a good day.